Hi there, and welcome to the second class of the Archimedes Academy by IMSystems. As discussed in the previous lectures, this and the upcoming two classes we're going to cover the three most common drives in robotics. And today we start with a lecture about cycloidal drives. So how does a cycloidal drive work? Well, you have a disk that is spinning with some lobes at the end. It is spinning through some pins. And well, here you see all the components, and it starts with this input shaft that's rotating around in a bearing, but as you can see, it's not in the center. This is called an eccentric bearing, due to which one of the sides is constantly pushing the rest of the drive. And therefore, this yellow disc starts spinning around and get those lobes in between the pins. And there's one more pin, so it will, every time the green one turns around, this one will move one pin. And that's why this purple one is going way slower. And I already explained that the purpose of a drive is transmitting torque with a certain ratio. Well, that can also be calculated in this way, because the ratio of a cycloidal drive is calculated by taking the amount of pins, these silver things, minus the lobes, those are the yellow ends, divided by the lobes. In this case, there were 11 on the outside, 10 on the inside, so the ratio is a difference of 10. So this side, the purple side, is 10 times as slow, but has 10 times the amount of torque. And also for further classes, we're first diving into some terminology before I'm going to explain the advantages and disadvantages of a cycloidal drive. These are the ones I want to run over. So the first one is the torque density. And torque density is the torque divided by the weight. That's why it's also called the torque to weight ratio. So it's actually a measure of, at the normal operational torque, how much can I put through the system in for a certain weight. So how much torque per weight can I get? And then there's efficiency, and efficiency is very important because it's the power that goes into that comes out of the system divided by the power that goes into the system, because not everything will come out, and that is because there's always components that have certain amounts of friction. So and that's just when two things collide. It doesn't necessarily have to be a bad thing, because well, in the past we also made fire by this thing, and sometimes you can even get it directly, like when sharpening your knife, and also a very small portion of the energy is lost due to sound next to the heat that comes out. And I already said power in versus power out. Maybe it's also good to know that power is the rotational speed times the torque. And then you maybe remember this slide from last lecture, what a drive does. And it goes all the way, if you use the proper way, to the front, to the robot application. And Morgan, behind the camera, what happens if you go to the other side, you think?
Well, I don't know.
And we went to the front, and then we go, if we turn it around.
Well, it's supposed to move back, no?
Yes, to the back. So if we go from the front to the back, and a drive can do that, but it's very efficient. What would we call that? Very good, backdrivable. It's if it's very efficient, because there's always these internal frictions I was just talking about. But also these frictions are multiplied by a factor of 100. So only in efficient systems it's still smooth enough so you can put it in the other direction. And now you will see that you have a very heavy applications that moves very slowly, and that on the other side the windings are going very fast to generate electricity. So that's a property that some types have and is relevant for certain applications. Okay, enough terminology for today. Let's talk about the advantages and disadvantages of a cycloidal drive. And a cycloidal drive has a lot of pretty nice properties. So it has a very high gear ratio in a compact package. So That's always the lighter the better for a robot arm. And also quite high in the efficiency. And torque density, which we just explained, it's also high, so a lot of torque in a very small package. And not only at operational speeds, but it's also very robust against peak torque. If a robot smashes into something, a cycloidal drive will be able to withstand that the best. Quite high precision, which is also very nice, and the low noise is also good compared to other drives. And we just talked about backdrivable. When the ratios are low, it's possible with a cycloidal drive. But there are also things to dislike, and that's first of all that it's quite expensive. There are way cheaper solutions. And vibrations. You can imagine that if these discs are spinning, it goes like kadoom, kadoom, kadoom throughout the whole system that wants to follow. So sometimes they make a symmetrical system to balance it all out with two of these and another plate that goes in exactly the opposite direction to counteract. But then it gets more bulky and you don't have that favorable torque density anymore. And another thing, you heard me say a lot, it's quite expensive, or in the previous slide, it's quite high precision, quite high efficiency. Well, that is because the cycloidal drive is in most performance criteria pretty good, but not great. In most things, there's another drive that's better than it, but they suck at some other properties. And cycloidal is just generally pretty good in a lot of stuff. And that's why people choose it. Alright, so this was my lecture about the cycloidal drive. Next time we will go on with the harmonic drive. And if you have any questions or comments, please leave them below, and I hope to see you the next time.